It is the 3.4 from your science textbook, from the page number 37. Page number 37, and the title of this is Writing Chemical Formulae. Writing chemical formulae. So, we know the symbol. Symbol is known to us, ions. Its definition and examples also are known to us. Okay. Now, next, what is formulae? Formulae is the plural form and formula is the single form. So, what is formula? Formula is the symbolic representation of a compound. Symbolic representation of compounds. Symbolic representation of compounds is called as the formula. Is the also you can see this, that the chemical formula of a compound is a symbolic representation of its composition. Okay. So, composition. What is composition? Do you know what is composition? What is composition? Suppose I told that ammonia. What are the compositions here? What are the, first of all, what are the elements here? Here the elements are nitrogen, one atom, and hydrogen, 3 atoms of hydrogens are there. Okay. So, these are the compositions, that is the number of nitrogen atom is 1 and the number of hydrogen atom is 3. Okay. So, this is the composition, that means the number of the atom, the specific atom, and also it can be represented by some percentage also, that is if we percentage it is, then nitrogen becomes the 25% and hydrogen becomes 75%. This is also comes under composition. Suppose in an alloy, 20% of tin, that is Sn, 20% of tin and 80% of copper. This is the composition of an alloy. It is also called the composition. Here it is represented in the percentage term. Here also it can be represented in the percentage term, but as the elements are is the whole number, so it also may be represented by numbers. Okay. So, this is also called as symbolic representation of the compounds or symbolic representation of the composition of any compounds. This is the definition of the formula. So, you have to remember is what is the formula, and let us come to the some examples. Okay. So, first of all we have to know the name of the ions and its symbolic representation. Already some simple ionic forms was discussed, that is sodium Na plus, calcium Ca2 plus, magnesium 2 plus, magnesium Mg2 plus, and you should represent it in correct manner, that is suppose Na plus, it is the wrong one. Sodium plus, it is also the wrong one. Na small n, this is here, this is the right one. This is also the name, that is first letter in the capital, then the small letter, and the plus, as it is a charge, it should be represented as a superscript of that symbol. Okay. So, these are not the correct representation of the elements. Here Na plus should be represented in that manner. So, this is the symbolic representation of an ion. Now, come to an anion. Suppose phosphate. Phosphate, the formula for phosphate is PO4 3 minus. Okay. Now, it is the correct one, but PO4 3 minus, it is not the correct one. PO4 3 minus, it is not also correct. So, find it. Here the phosphate number of phosphorus atom is 1, number of oxygen atom is 4, and this is the charge. This is the charge, and here PO4 all are in the size of the letters are similar here, okay. But it is not that. Here 4 does not symbolize anything here, but here 4 symbolizes that number of oxygen atom is 4 here. Here what is the wrong here? Here 4 is with the oxygen, but here the correct manner, that is the representation of 4 atom of oxygen is not correct here. So, this is only the correct representation. Now, come to any more examples regarding to the anion. Suppose nitrate. Okay, so the compositions here is nitrogen and oxygen, and what is the number of nitrogen atom and oxygen atom? Nitrogen is 1, oxygen is 3, and then come to the charge. Here it is having 3 minus NO3 minus. So, NO3 single minus 1 minus, this is the correct representation of that. But if we represented it NO3 minus, it is the wrong one. NO3 minus, this is also wrong one. So, you have to represent it in the correct manner. Okay, so this is the symbolic representation of nitrate, previous one was the representation of phosphate. Now, suppose bicarbonate. Carbonate, first carbonate. Carbonate, here the compositions are carbon and oxygen. Carbon is 1 and oxygen is 3, and the charge is -2, because as it is an anion, so its charge is negative here. So, how to represent carbonate? CO3 2 minus, CO3 2 minus, this is the representation of the charge. Okay. Next one, CO3 bicarbonate. Bicarbonate, how to represent bicarbonate? Here the compositions are hydrogen 1, carbon, that is 1, and oxygen 3, and the charge is 2 minus. Okay. So, HCO3 minus, it is not 2 minus, it is only single minus. So, minus 1 minus. So, it is the representation of bicarbonate. Next come to the more examples, sulfite and sulfate. Sulfite, SULPHITE, sulfite, sulfate, and then sulfide, thiosulfate. Okay. So, first one sulfide. Here the compositions are sulfur, that is 1, oxygen, that is 3, and the charge is 2 minus. So, how to represent it? S. So, I am writing down the formula for this, SO3 2 minus, it is for sulfite. Now, come to sulfate. S, number of atom is 1, oxygen number of atom is 4, and the charge is 2 minus also. So, here the formula representation of will be SO4 2 minus. Now, come to the sulfide. Sulfide, it is only one sulfur atom S, but the charge is 2 minus. So, the representation will be S2 minus. And in the last one, thiosulfate, here S equal to 2 and oxygen equal to 3. So, and the charge is 2 minus. So, the formula will be S2O3 2 minus. Okay, these are the anions of sulfur. First one sulfide, sulfate, sulfide, thiosulfate. Understood? So, you have to remember this with the charge, because as you make any mistake regarding the representation of charge, then the exact formula will be also be wrong. So, sulfide is SO3 2 minus, sulfate is SO4 2 minus, sulfide is S2 minus, and thiosulfate is S2O3 2 minus. Another one is there, oxide. Oxide. So, here the composition is only oxygen is present, only oxygen, and here a number of oxygen atom is also 1, but the charge is 2 minus. So, the representation will be O2 minus. O2 minus, it is the oxide. Next one, that is sulfide, nitride, nitride, nitrate. These are also there. Nitride, it is number of oxygen nitrogen atom, as nitrogen is 1, okay, and the charge is 3 minus. So, the representation will be N 3 minus. Nitrate, here nitrogen equal to 1, oxygen equal to 3, and the charge is minus 1 or 1 minus. So, the NO3 minus. Okay. So, these are the common anion, these are the name and formula of the common anion. Okay. And the cation is known, that is iron, magnesium, calcium, copper, zinc, aluminium also. These are coming with their valencies. The general state, oxidation state is also their valencies. What is valency? Here with respect to the metal ion, the valency is that the number of electrons liberated, to form a stable electronic configuration is called as valency. So, here for example sodium. Now, you will come to know about the in the atomic structure that sodium having the electron number of electrons, that is of 11, and it is representation as 281. So, last cell contains 1 electron. If 1 electron is eliminated from the last cell, then it will get Na plus having 10 electrons. So, the charge is due to the when the number of proton and electron is equal, then the charge is neutralized, but if any electrons will be eliminated from the last cell, okay, due to the formation of any further purpose, that is formation in the compounds or to take part in the reaction, then it is the ionic form. Another one, that is magnesium. The stable the atomic number is 12 here, and if we break the electrons, then it is 282. Okay. So, last cell contain 2 electrons. So, magnesium, when it will forms the positive charge, it will form the stable positive charge, that is of 2 plus. Okay. Sodium, magnesium, aluminium. Aluminium, its electronic atomic number is 13, and if we break the electrons according to the shell, then it becomes 283. So, the number of electrons in the last cell is 3. So, if it eliminates the 3 electron, then it would be the Al3 plus. Okay. So, aluminium 3 plus, magnesium 2 plus, sodium plus, this is the simply formed cations. Some more examples are, suppose silver. Silver, here in the last cell it is having also 1 electron. So, its stable electronic configuration is silver plus 1. But some elements also shows variable valencies, that for example iron. Iron forms complexes in the plus 2 and plus 3, copper plus 1 plus 2, silver plus 1 plus 2, but in the latter case, that is silver and the copper, the plus 2 state is the stable, but for silver it is plus 1 state is stable. But iron here plus 2, that is iron sulphate, ferric sulphate, these also they are stable in the plus 2 and plus 3 oxidation state. The plus state is called the As acid or the As complex, and the ic state is called the ic complex, that is the higher oxidation state or higher valency. In the same way, copper, it forms copper 2 plus. Okay. So, another example, that is zinc, Zn 2 plus, manganese form a varieties of complexes in from plus 2 to plus 7. Plus 2 it is having plus 2 to plus 7 range of oxidation state or valencies. Manganese here it is, I am written here plus 4, but generally manganese is plus 2 may be there, that is manganese oxide. So, these are the commonly used cations, and also the zinc is written, okay, barium and calcium. Barium Ba 2 plus, calcium Ca 2 plus. If you follow the electronic configuration of that, these 2 plus or these 2 plus are coming from the to somehow to stabilize the electronic configuration. Okay. So, these are the name of the simple cations and anions we know. Now, come to the how to represent the formula. Okay, so first start with sodium chloride. Sodium chloride. Okay, so here sodium and chlorine. Now this breaks into two parts. This is the metallic part, or this is the non-metallic part. So, metallic part forming the cations, metallic part forms the cation and non-metallic part forms the anions. So, here metallic part, the sodium, just I told you that the stable electronic configuration, to form the stable electronic configuration it is monopositive, and the chlorine, it is a short of 1 electron, it will takes up that electron, it will form the minus 1. So, it is plus 1 and this is minus 1. Now, just write in this manner Cl minus 1. Now, cross multiply it, that is Na which goes with, here only take the numeric, one, here also take the numeric one. Now, come to the Na 1 Cl 1, but when here it is 1. So, we need not to write down 1, here only we will write NaCl. Okay. Now, check that the charge is balanced or not. Here single positive and here single negative. So, here charge is neutralized. Okay. So, this is the formula for sodium chloride. Okay. Now, coming to some more examples. Suppose some simple one, that is ammonia. Ammonia, the compositions are nitrogen and hydrogen. Okay, number of nitrogen atom is 1 and number of hydrogen atom is 3. Now, cross multiply it. So, in number of nitrogen atom is 1 and the number of hydrogen atom is 3. Sorry, number of nitrogen atom is 3, number of hydrogen atom is 1. This also comes from the valency. So, it will be in H3. Just for example, H2O. So, it is ammonia. This is water. The another name of water is aqua. Now, in water, hydrogen and oxygen. Number of oxygen atom is in the water molecule is number of oxygen atom is 1 and the number of hydrogen atom is 2. Now, cross multiply it, it will be H2O. Next, come to the one more example, that is methane. Methane. Methane is a compound of carbon and hydrogen. Now, carbon is having the valency of 4 and hydrogen having valency of 1. So, when we cross multiply it, then we have to think about the valency also, because we have to neutralize the charge. So, if the hydrogen having hydrogen as its valency is 4 and its valency is 1. So, cross multiplying it CH4. Another one example, that is carbon dioxide. Carbon dioxide. Carbon, its valency is 4, oxygen, its valency is 2. Okay. So, the formula will be cross multiplied C2O4. Now, simplifying it, we will get CO2. Okay. So, from there just we have to write down the valency. Here nitrogen's valency is 3, hydrogen valency is 1. Here hydrogen valency is 1 and oxygen valency is 2, and then cross multiply it to get the exact formula, that is here NH3, H2O, CH4, CO2. Now, come to another one example, that is sulfur dioxide. Sulfur dioxide, sulfur and oxygen. Okay. So, here the valency of sulfur is 4, valency of sulfur is 4 and oxygen is 2. Now, cross multiply it S2O4 and then simplifying it, we will get SO2. Okay. So, these are the simple formula. On the next day, I will discuss the more formulas regarding to that.